Hi, I'm John.
I'm Nick.
I'm Hunter.
I'm Sam.
I'm John.
And this is our nuclear power presentation.
Hello and welcome to our nuclear power presentation. In this presentation, we'll be going over the many forms of nuclear power and how engineering has got us to where we are today.
In 1932, James Chadwick discovered the neutron, and he also discovered that it had a neutral charge. Enrico Fermi, he later built on this by discovering that a neutron could be used to split a uranium atom into multiple elements. And later on after that, Lise Meitner, Otto French, and Fritz Strassmann all worked together, and they found out that when uranium is split by a neutron, it splits into barium and krypton, and also releases three extra neutrons as well. And these three extra neutrons led to the development of water drop theory, which compared neutrons to a water drop. Since when a water drop hits the surface of water, it'll split into multiple water drops when it splashes. And these neutrons that are released released from the uranium, these can cause a chain reaction with other uranium atoms until a half-life is reached.
A nuclear fission reaction begins with a free neutron colliding with the heavy nuclei of a fissile radioactive isotope. Fissile meaning that the isotope is capable of undergoing nuclear fission. The collision causes the compound of the nuclei of the isotope to enter an excited state, meaning the excitation energy is greater than the critical energy. This forces the compound neutron to break apart, releasing incredible amounts of energy in the form of radiation and kinetic energy, and also fission products. These products consist of radioactive elements and 2 to 3 free neutrons. After the reaction, the element produced will eventually decay into non-radioactive elements, while the neutrons have the potential to collide with more fissile radioactive isotopes, causing a nuclear chain reaction.
Nuclear power plants harness the heat from nuclear reactors to generate steam, which in turn powers steam turbines connected to generators that produce electricity. These nuclear reactors are often used on a small scale in submarines and aircraft carriers in order to give a constant fuel supply that allows ships to be out at sea for long periods of time without the need to refuel. Despite its enormous capabilities, nuclear power only makes up for around 11% of the world's electricity, as it has long been held back from stigma surrounding nuclear meltdowns as well as large costs to develop and build nuclear power plants.
Nuclear fusion is the process in which two hydrogen ions, known as deuterium and tritium, are increased to tens of millions degrees Celsius to form a hydrogen plasma at which the ions can fuse together. This fusion creates one loose neutron and a helium atom, and energy is produced in the form of gamma rays. Scientists in Germany have managed to reach the key step in nuclear fusion, which is creating and maintaining a hydrogen plasma. And Elon Musk has theorized terraforming Mars using nuclear fusion bombs.